Hello and welcome back to review my channel, math_exe. Today I'm going to talk about the problem with infinity. So first let's define what is infinity, labeled with this symbol right here. Some would say it as unlimited, some would say it is unbounded, and some would say it is greater than any finite number that you can possibly think of. So if you consider a number line, so let's say this is 0, and then let's say you think about a considerably large number, and I'll just label something right here. So let's say that is 10 to the power of 123, for example. With this, there must be at least one number that is exactly greater than 10 to the power 123. So this is true for any number you can think of. So in the case of finite numbers, you can actually take a number, and then with that number you can determine the numbers that are greater than that number. And if you continue this, beyond this number line lies infinity. And this infinity is considerably infinitely larger than any standardly greater number you can think of. For example, 10 to the power of 123, or for example, let's see, some crazy big number to the power of some crazy big number as well, something like that. Or possibly add that with another crazy big number, and so on. This is actually infinitely smaller than infinity. So you can imagine then how big infinity is. And the problem with infinity is there could be some paradoxes formed with this infinity. And the one that I'm going to demonstrate with you is called Hilbert's paradox of the Grand Hotel. Alright, consider a hotel with infinitely many rooms, and assume that that hotel can pack up that many rooms. So let's say that each rooms are filled with exactly one person or one guest. And consider another person that wants to check into to this hotel. And you may think that, well, this person cannot check in because all of the rooms are full. But if you do this trick, so I'll just put this little red guy right here. So if I'm going to draw the rooms yet again, but this time each of these guys will move one room to the right. So this guy in room 1 will move in room 2, right there. I'll just label these rooms first. And by the same thing, this guy in room 2 will move to room 3, and this guy in room 3 move to room 4, and so on. And if you continue this over and over again, you'll actually end up with one empty room for the new guest to check in. And you may think, well, this is impossible. How can you have like a certain number of rooms and then add one and still have the same number of rooms with one guest each inside that room? And I would just ask you, well, if we consider just a finite number of rooms, let's say just 5 rooms, you won't be able to do that, because if you have this person to check into room 1, then you will have 2 guys in room 5. Oops, I just messed up. So you have 2 guys in room 5. And assuming that you're trying to arrange these guys such that each room must have exactly one person, You won't be able to do that. That's impossible with this extra one gas. But if we consider infinitely many rooms, let's say we add another room, room 6, with one person each, with one person inside it. I'm sorry. We can move this guy to room 6. So we just remove that guy and move it to here. Now the problem is we have two guys in room 6. Well, considering the case of infinitely many rooms, you can add another room, room 7, and then you add another room and so on. So each of these two guys, so one of these two guys inside these rooms must move to the room on the right hand side of them. And you may be wondering, well, when should we stop? And I'll probably ask you, well, which room will have two persons in them? And of course, you cannot have two persons in one room because we are considering infinitely number of rooms. And infinitely number of rooms, well, we've just defined infinity as a number greater than any finite number. So yeah, and what this tells us is that if we have infinitely many rooms, and then if we want to add, well, consider an infinite number of rooms with one guest inside them, and if one guest wants to check in, you can do that. You just need to do the shifting thing. So just shift the guys to the right side of their rooms. So therefore you have something that looks like this. And notice that these and these rooms are exactly the same, and they are both equivalent to infinity. And then we have this one last guy right here, which is just one room. So what that tells us is that infinity plus 1 is equal to infinity. Now that kind of seems very weird in the case of finite numbers, because you cannot like add a certain finite number n and then add it by 1 and it still result in the same number as you started with. And you can try this with any finite number, and you can even bother with complex numbers, and those will not work. So this is a very strange paradox, and actually this paradox that this really gives us, well, that this really gives us mathematicians to learn more about infinity. And one of those aspects is in calculus, more specifically about limits. So assume we have a limit as a variable x goes to infinity of a certain function f of x. So what that means is, if we consider the graph of f of x, let's say something like this, what would this y value approach as x goes towards infinity? So infinity is around that way. What will be the y value for this? And for this, there are many techniques to derive limits for x goes to infinity. And for more about that, you may kind of Google or search about calculus or limits. So yeah, if this doesn't convince you that infinity is weird, I don't know what would. Because this is strange. Because, well, as I've explained before, you cannot add a finite number by 1 and then still result with the same finite number. And that's going to wrap it for this bonus video, and thank you guys for watching, and goodbye.